So our topic today is electromagnetic wave field. So we have so our topic today is electromagnetic field. Of course, we can call it EM field for short. Is that taken? So, what is electromagnetic field? As the name implies, electromagnetic, which means it's a field that's got both electric field and magnetic field interacting together. So we define electromagnetic field as is a field in which there is an interaction of both electric and magnetic fields. So we define electromagnetic field as the field in which there is an interaction of both electric and magnetic fields. You see? So we have electric field and we have magnetic field. We have electric field on one hand and magnetic field on the other hand. So the mutual interaction of them is what we call gives rise to what we call electromagnetic field. And these two fields, electric and magnetic field, are interacting with each other at 90 degrees, that's at right angles. And then we have magnetic field. They interact with each other at 90 degrees. So now electromagnetic field is considered to have its separate existence in nature. That is, it exists independently on its own. It is not electric field, it's not magnetic field, it's just the interaction of both of them. You see? Now, it's also one of the four fundamental fields in the Standard Model. The other ones being, we have the nuclear strong force, the nuclear weak force. We also have the gravitational force as well. You see? So we define electromagnetic field as the field in which there is a mutual interaction of both the electric field and magnetic field. You see? So now, we have experiment shows, when you have a charged particle in an electric field, what happens to it? Now, experiment shows that when you have a charged particle in an electromagnetic field, that charged particle experiences what we call the Lorentz force, and it's given as F is equal to Q E plus V cross B is equation 1. You see? So when we have a charged particle in an electric field, so we say a charged particle in an electromagnetic field experiences what we call the Lorentz force. And the Lorentz force, like I told you, is given by F is equal to Q E plus V cross B. Or It can also be given as F is equal to Q bracket E plus VB sine theta. Either of these two equations are fine. F is equal to Q bracket E plus V cross B, or F is equal to Q bracket E plus VB sine theta. Now, if you look very carefully, when you expand these brackets, we have F is equal to QE plus QVB. That's equation 1 becomes this, or equation 2 becomes QE plus QVB sine theta. You see? So if you expand these two brackets, you get these two equations. Now, there's something I want to draw your mind to. You can see that the total Lorentz force is actually the electrical force. Okay, let me put it this way. Where Q is equal to the charge, E is equal to electric field intensity, or electric flux density, we have V is the velocity of the particle, B is magnetic field intensity, you see. So Q is the charge, E is the electric field intensity, V is the velocity of the particle, and B is the magnetic field intensity. Now, or the magnetic flux density, any one of them. Now, there's one thing I want to draw your mind to. You see this one, QE. Remember that by definition, E is equal to F over Q. That is the force per unit charge. And when you do a cross multiplication, we have F, which is the electric force, becomes QE. And that's exactly what you have here, you see. Now, also from magnetism, we have B is equal to F over Q. Yeah. Okay, so we know that F is equal to VBQ, or QVB sine theta if you want. You see, so you can see that the equation that we have here is just a combination of both the electric field, or the force, the electric force, and then the magnetic force. Of course, this one is the electric force, and this one is a magnetic force. You see, so a charge in an electromagnetic field experiences both. It experiences a force which is given as the electric force plus the magnetic force, and that's what you have here. See.